Hello class, today I'm going to show you how we can have coupled thermal and structure analysis in ANSYS. For this workshop, I just draw simple piston. As you can see here, it's very simple in SolidWorks. You can use any other software. And if I want to show you the different steps, I just draw a cylinder, then shell it, then cut for the rings, one cut, and then I copy it 3 times to have 3 rings for this piston, and then I cut this hole for the rest of the attachment to be able to have a fixed support there. So as you can see, this is a simple piston drawing. It's a solid part, and I'm going to save this as IGES file. So IGES file, you can see here I already saved as IGES file. Okay, so here in SolidWorks there's no problem, and it's very clean and smooth surface. Let's go and work with ANSYS. Steady state thermal is going to be dragged, and for the geometry I'm going to import the geometry we just saved as IGES file. Let's open the geometry and make sure everything we need is available there. Okay, so it takes a little bit time for the ANSYS to open. Okay, geometry is here. It is cylinder, piston, but as you can see here we have a surface. It should be a solid, and it's somehow it's divided to 2 sections, as you can see, and it's not usable. We call this type of geometry dirty geometries, and basically you need to work further on these geometry to be able to make it usable. Basically, this transferring file and importing IGS file into ANSYS, we're losing some information, and we need to repair this dirty geometry. Let's go open the repair tab. First thing, I know that this is surface, so ANSYS or Space Claim find out there is some gap somewhere. I don't know, there's a gap. If there was a gap, automatically ANSYS converts the solid to the surface. So I need to stitch it. Let's click stitch, and it's going to automatically look for the open surfaces. And as you can see, I didn't do for the SolidWorks, but somehow there is a gap there, and we can click it to fix this gap. Now it is converted to the solid, and I can use it, so no problem here. But I want to make sure there is no problem with my geometry and reduce all the difficulty I may face later. Let's check gaps. If there is a gap somewhere, okay, no gap, great. Any missing surface? No missing surface, very good. How about let me see. Okay, one more thing. When I was cutting these ring places, it was like a rectangle, and then I filleted. So very easy and simple geometry. But when you import in ANSYS, they may change a little bit, and ANSYS is going to figure out and say, okay, this is a complicated geometry. Later on, when you're applying mesh, it's going to be problem. So I can ask to simplify those geometries. If there is a like a straight cut, make it a straight cut. Don't cut that line to several pieces. So let's check if we can simplify. It says 28 areas can be simplified. So why not? Let's simplify those areas. Nothing changed. Just connected the geometries. If it's line, we divide it to 5, 6 different parts. They're connected now. If there are some surfaces, now they're connected. Let's see any small faces, because sometimes when you're drawing, they say, oh, there's like a 0.5 millimeter small surface somewhere, which it just appears there, or when you're drawing you make a mistake. So no small surface. How about inexact edge? So here says when we draw those points, they're not exactly fit over each other, and we have this problem. Let's ask ANSYS to fix this problem. So 127 points, they're not 100% over each other. Some of them, they're not they're over each other, they pass each other, so they're not gaps. So if it was a gap, we should have had surface. So it shows they're not perfectly over each other, like up to several digits. They may create a problem later on, or they may not. If we could fix them, why not? Okay, now we fixed 127 problem, which was, even if I zoom it, I may not be able to see, but if I could have a point here and from left side, another point from right side, and they're not 100% matching each other. And I didn't know that. For my drawing it was okay, but for the ANSYS can see those and identify those. So I fixed everything. Now my geometry should be pretty good without minimum minimum problems. So not anymore dirty geometry. Good enough. Let's start our investigation. Now I'm going to apply some thermal loads. Basically, for the thermal investigation, temperature is going to be the load. Because the geometry is piston, I'm going to say the top side of the piston, for example, is I don't know, 700 degree, 800 degree, because we have combustion happening there. So it depends on the type of engine. We may have different exact value for the temperature. So I'm going to just randomly select the temperature for top, and then this piston should cool down, otherwise temperature just raise and destroy the piston. So from the sides of the piston we should cool it down. So I'm going to apply some cooling effect for the sides. Okay. Let me generate a base mesh for this geometry. Okay, so as you can see, it's a very coarse mesh, but I'm going to accept this. I'm not looking for the exact or accurate solution, just showcase. So this is the mesh, not touching the mesh. Insert temperature for upper surface. Let's apply, for example, 700 degree for this piston, and I need to create something to lose that temperature, otherwise it's not a well-defined problem. So convection from the sides of the piston. So basically we have a cooling system around the piston, so we are going to have a convection of this heat to outside. So let's select the sides. I'm clicking control button and just dragging everywhere gradually to select all the surfaces necessary. Maybe I need to zoom it a little bit more. This angle. I think I selected everything. Yeah. So 44 surfaces selected for the convection. So okay, let me change the unit because I don't know. So this coefficient, film coefficient, which shows how fast I can transfer heat. Let's go with 300, and temperature, ambient temperature is considered 22 degrees. Okay, so we have a hot surface up there, and the cooling from the sides. What type of solution I want? I want to know the temperature and for example total heat flux. Good enough. Let's solve this question. Because I didn't refine the mesh, so my solution is going to be very fast, and we're not wasting that much time waiting for the solution. Okay, so temperature, as you can see, starts from 700 to 94, so we have a pretty good cooling operation happening there. And if I want to show you how this happens, gradually temperature penetrates inside the piston, and because of the cooling happening from the sides, we're not letting piston temperature to raise above 94 degree, or the parts lower than this section have experienced this high temperature of combustion. And the other one shows the heat flux, the highest heat flux. As you can see, we have the highest heat flux there, and when you can see the unit watt per meter square shows this area we have the highest temperature watt or energy passing through the surface. The first ring is going to be very important to be resistance to the temperature, high temperature. Gradually this heat flux decreases from yellow to green, green to blue. So the first one is very important. The other two has less importance in terms of temperature resistance. Okay, we investigated in terms of temperature. Let's go and include the structural analysis. So where are you? So I'm going to put here because I want to have the result of the thermal analysis inside my structural analysis. Okay, so this time I'm going to apply the boundaries related to the structure analysis. The first thing is going to be support, so I'm going to apply fixed support to this section. I could have connect these surfaces in the repair section when I was repairing my geometries, but I didn't do it. But still it's okay, but the number of clicks I'm doing to select the stuff would be a bit, it's more than the time I could connect those, but still it's okay and no problem for me. And I need to apply some type of force or pressure. So where are you? Here. So let's add different pressure for different rings. For this one I'm going to apply I don't want to type, so I want to be in megapascal. So let's say 9 megapascal for the first ring. Duplicate this, duplicate this. For the second ring, which is here, I want to be 9, this one for example 7, and for the third ring let's have 5 megapascal of the pressure there. And what type of information? I'm looking for total deformation and just stress, Mrs. stress as example. Okay, it's very fast, and let's see the results. Okay, total deformation. You can see this is the, of course, is the exaggerated one. Let me go and make it, for example, 3 scale, and you're going to see basically we have the highest deformation at the upper surface. It's like a ring here, and that is why when they manufacture these pistons, this upper surface, the outer part, must be very strong, resistant to the temperature, and friction resistance, because it's going to a little bit increase and expand, so it's going to have some friction to the side. So this upper part is very important. That is why when we have a damaged piston, usually this area is the damaged area. How about let me show you how deformation works when we apply temperature and pressure. And for the stress, you can see the fixed supports area is we are going to have the upper here we have the highest stress. Okay, thank you very much. For this workshop, we learned how we can combine thermal loads and structural loads. See you next time.